Hello, everyone, and welcome back to our series on the essential foundations of mathematics. Before we dive into today's lesson, if you're serious about mastering this and want the complete roadmap I'm following, you can grab the full guide in the link below. While you're there, I've also put together a 100-question arithmetic basics test. It's free to download, so you can test yourself and see where you stand. If you have any feedback or questions, drop them in the comments. I'm looking to improve this for you every day. Now let's get straight back into the lesson. Today, we are focusing on powers and exponents. This topic is a core component of the arithmetic syllabus. Our objective is to make powers feel obvious and non-threatening. Once you understand that exponents are simply a shorthand for repeated multiplication, they lose their mystery. The core definition: a power, or an exponent, is a mathematical notation that indicates how many times a specific number is multiplied by itself. It consists of two parts. The base. This is the primary number that is being multiplied. The exponent. This is the smaller number written above the base, which tells you exactly how many times to use that base in a multiplication sequence. For example, 2 to the power of 3 is written as a large 2 with a small 3 above it. This does not mean 2 times 3. Instead, it means 2 times 2 times 2, which equals 8. Essential rules of exponents. In professional mathematics, we use several consistent rules to manipulate powers. Understanding these logic-based patterns will prevent you from having to perform long, manual calculations. Multiplying powers with the same base. When you multiply two powers that share the exact same base, you keep the base and simply add the exponents. Why? If you have 2 squared times 2 cubed, you are essentially multiplying two groups of 2's. 2 times 2, multiplied by 2 times 2 times 2. That is a total of 5 2's being multiplied. The result: 2 to the power of 5, which equals 32. Dividing powers with the same base. Conversely, when you divide powers with the same base, you subtract the exponent of the divisor from the exponent of the dividend. Example: 5 to the power of 4 divided by 5 squared. You subtract 2 from 4 to get 5 squared, which equals 25. Power of a power. When a power is itself raised to another power, you multiply the exponents together. Example: 3 squared, all raised to the power of 3. You multiply 2 by 3 to get 3 to the power of 6, which equals 729. Power of a product. If you have a multiplication problem inside parentheses raised to a power, you must distribute the exponent to every number inside those parentheses. Example: the product of 2 times 3, all squared. This becomes 2 squared times 3 squared, which is 4 times 9, equaling 36. The 0 and 1 exponents. There are two special cases that often cause confusion, but are very simple once understood. The 0 exponent. Any non-zero number raised to the power of 0 is always equal to 1. For example, 7 to the power of 0 equals 1. The 1 exponent. Any number raised to the power of 1 is simply itself. For example, 7 to the power of 1 is just 7. Exercise module. Now, let's test your understanding with these surgical diagnostics. I want you to focus especially on these first 4 questions. Question 1. What is 2 squared times 2 cubed? Hint: use the addition rule for exponents. Question 2. What is 5 cubed divided by 5 to the power of 1? Hint: use the subtraction rule. Question 3. Calculate 4 squared, all raised to the power of 3. Hint: use the multiplication rule for exponents. Question 4. What is the product of 3 times 2, all squared? Hint: distribute the exponent. I strongly encourage you to finish the rest of the exercises, including 7 to the power of 0. Remember, Any hesitation here means you should repeat these rules until they feel like second nature. Summary. In summary, an exponent is nothing more than repeated multiplication. When working with the same base, you add exponents to multiply and subtract them to divide. When raising a power to another power, you multiply the exponents, and always remember that any number to the power of 0 is 1. A firm grasp of these rules is the only way to avoid unnecessary pain later when we move into algebra and more complex roots. Speaking head transition script to the next lesson. Excellent work today. You've taken the magic out of exponents and replaced it with clear, logical rules. You can now scale numbers up through repeated multiplication with total confidence. But what if we need to do the exact opposite? What if we have a large number and need to find the original root that was multiplied by itself to create it? In our next lesson, Roots, we will learn how to reverse the process of exponents. We will discover how to track a number back to its source, completing your understanding of how numbers grow and shrink through multiplication.